This is the video notes for lesson 5.1, Business Sense. This is actually part 2, where we're going to continue with the lesson and go to task 5. Okay. So here's task 5. It says both paint companies allow the customer to purchase their own paint. Carlos has done some research and found the following information. He found that Handyman Tools and Supplies sells a small painter's kit that contains 2 paintbrushes and 4 rolls of masking tape for $16. They also sell a large painter's kit that contains 2 paintbrushes and 15 rolls of masking tape for $50. Carlos' dad is planning to paint a couple of rooms in their house and has offered to buy any leftover supplies. Carlos is trying to figure out how much he would charge his dad for each paintbrush and each roll of tape. To keep track of the information, he's written the following equations. Clarita looks over his notes and asks, what do P and R stand for? So, the way that Carlos has done this is he has used P to represent He's used P to represent the cost of a paintbrush. So cost of a paintbrush. And he's used R to represent the cost of 1 roll of tape. Okay. Before I move on with the next part, I want to look at the 2 equations that he created to kind of show how he created them and how we can easily graph them. So this top equation, 2P plus 4R equals 16, that is the small painter's kit, right? 2 paintbrushes plus 4 rolls of tape equals a total of 16. This is in standard form when we have our combination of variables on the left and our total on the right. If I wanted to find a quick way to graph this, I can actually graph it quickly using X and Y intercepts. So I'm going to do that for the top equation. So let's find our intercepts really fast. Intercepts. Okay. So in order to find my intercept for P, which P is like X, is PX. Actually, we're going to graph P as Y. All I would do was I would set 4R to be 0, and then I would divide 16 by 2. So I would know that my intercept for P is 8, right? 16 divided by 2 is 8. So my intercept for P is 8. And then I would set 2P to be 0. And then I would divide 16 by 4. And then I would know that my intercept for R is whatever that is. So that is 16 divided by 4 is 4. The second standard form equation is the large painter's kit. 5P plus 15R equals 50. And I can do the same thing to help me easily graph this. I can find the intercepts. So I'm going to cross out 15R, set that to 0, right? And then I can divide 50 by 5. And that will tell me my intercept for P, which is 10. And then I can set the 5P to be 0, and then divide 50 by 15, and that will tell me my intercept for R, which is 3.3. Okay, so that's going to help me graph it in a moment. All right, Clarita says, I think I can find the values of P and R using a table or graph. Carlos says, I think I can find the values of P and R using algebra. All right, so we're going to show both a graphical strategy and an algebraic strategy. Okay, so that's why I found those intercepts over here, that's gonna help us graph it very easily. So P is acting like our y value. So I'm going to actually cross out the y value and say this is p, and r is like our x value. So we'll cross that out and write r. So in order to graph that first line, which is the small painter's kit, I'm going to put a intercept, a y-intercept at 8 on my y-axis, which is like my p-axis, right there. And then my x-intercept or r-intercept is 4. So then I put that here. And then I just connect them. This is the line that represents our first equation. Okay, now we're going to do the same thing for our second equation. We're going to use those intercepts. For p, I had 10. And then I had 3.3. So like right there, like a third of the way to 4. Okay, so then you go ahead and connect that. And my lines are not very good, so I'm going to redo them really fast. Okay, so let's try to do a better line here. Yeah, that looks way better. And then my two other intercepts, we're at 10 and 3.3. And then we just connect those and hopefully that looks better. Awesome. Do you see where the two lines are crossing? That is right there. That is our solution for the cost of one paintbrush and one roll of tape. Okay, so it's that ordered pair, which is 2, 4. 2 is the R, so 2 is the roll of tape. So we're going to say a roll of tape costs $2 each. And then a paintbrush costs $4 each. All right, so that's how we can solve it using graphing, right? I took the two equations that represented the small and large painter's kits. I found their intercepts, and then I graphed those intercepts and found where the two lines crossed, okay, right at this location. So that was our graphical strategy. Now we're going to do our algebra strategy. Our algebra strategy is called substitution. Okay, so I'm going to go over here and write substitution. So if you're ever asked to use substitution, this is the strategy that you're going for. Okay. The first step of substitution is to solve both of those equations for the small painter's kit and large painter's kit for P. Okay, so that's our first step. Solve both equations for P. Okay, so let's look at how we can do that. So to solve the first one for P, we would minus 4r from both sides and then divide everything by 2. So we would end up with P, let me zoom in a tiny bit more, P equals 16 divided by 2 is 8, and then the minus 4r divided by 2 is negative 2r. So that's our first one, solve for P. And then we're going to solve the large painter kit equation for P. So for that, we need to minus 15r from both sides and then divide everything by 5. So we end up with P equals, and 50 divided by 5 is 10, and minus 15r divided by 5 is minus 3r. Okay, so I've just rearranged the equations, solved them for P. Now we're going to do our second step of substitution, which is set the equations equal and solve them. Okay, the reason I can set these two equations here equal is because they're both equal to p. So I can actually replace this expression right here where the p is. Okay, so I go 8 minus 2r equals 10 minus 3r. I haven't changed anything. This is still equivalent to each other because 8 minus 2r is p, and I just did a replacement. Okay, and then we just solve it for r. So we're going to plus 3r to both sides. We end up with 8 plus r equals 10, and then we're going to minus 8 from both sides. And we get our answer for r. R equals 2, which is what we got by graphing as well. The cost of one roll of tape is $2. Now, to find our second answer algebraically using substitution, what we do is we take this answer that we just got and we're going to replace it in one of our two equations here in step 1. So I'm going to take this 2 right here, and I'm going to replace it. Let's just use the top one. I'm going to replace it right here where we see r. This is, again, this is the substitution method, right? So we're substituting, we're replacing with things that are equivalent, right? So this is our third step. So third step, sub answer back into one of the equations. And I could do either, it doesn't matter, I'm going to get the same answer. Okay, so I'm going to just use the top one. So I have p equals 8 minus 2. Instead of r, we're going to replace it with 2. So p must be 8 minus 4, which it is. P is 4, which was the answer that we got using graphing as well. So regardless if you use a graphing strategy or an algebra strategy, you will get the same solution. And we can write it as an ordered pair if we wanted to. So it would go 2, 4. This is our roll of tape. This is our paintbrush cost. Okay. All right. Hopefully that makes sense, and you'll have recorded this substitution example so that you can use substitution in the future. Let's go ahead and move on to our takeaways. All right, our first takeaway has to do with, while each equation in a system of equations has many solutions, the solution to a system of linear equations is, right? So this is the solution to a system is a single ordered pair, right? It's where the two lines cross, or where if you use substitution, where algebraically you solve for x and y, it represents a single ordered pair. A single ordered pair. And that single ordered pair satisfies both equations. Okay. All right. Systems of equations can be solved using tables, graphs, or algebra. So all three methods are completely valid. The solution to a system is revealed in different ways, and each strategy has its own pros and cons. So let's go over the pros and cons of each. So using a graph, how is the solution revealed? So this one is the most visual, right? It is revealed by showing a point of intersection. It's very visual. That's its biggest pro. A negative could be that it doesn't cross at a nice location. So it might not cross at an integer. Okay, let's go ahead and talk about a table. So how is the solution revealed in a table? It's revealed when we have the same outputs for both equations. Same outputs for both equations. Okay, a pro about this is that you can clearly see the rate of change or the slope. Clearly see the rate of change or the slope. A con could be that the solution, again, might not be at a nice location and might be between two values. So that could be an issue. Solution might be between two values. All right, let's move on to using algebra. Okay, how is the solution revealed using algebra? We find the solution by solving an equation that was created using substitution. Okay, a pro of this is that you will always get an exact answer. Even if it's a decimal, you'll get the exact answer. Con of using algebra is you can't really visually see what's happening like you can in a graph or table. Not visual. Okay. So as far as using substitution, I showed you in task 6 one way of doing substitution. So I'll detail that method, but there's actually a second method that we could have done. So let's detail our two methods. There are two methods for solving a system of linear equations algebraically by substitution. So the first method that I showed in task 6 was solve both equations for y. Okay, once you do that, then you can set them equal to each other. And solve. Okay, so that if you're starting in standard form, it's a little bit more work to change them so that they're as y equals, but it's not very hard to solve both equations for y. A second method is instead of solving both equations for y, you can just solve one of them for y. Solve for y. And you're still going to, you're not going to set anything equal here. You're going to substitute that expression for the equation that you solve for y into the second equation. And then sub that expression into the other equation where y is, and then solve. Okay, both of these methods, once you've solved for your first variable, then you'll have to go back and substitute and solve for your second. So don't forget that final step to go back and solve for your second variable. Sub answer back into one of the equations to get second answer. Okay, and that happens for both of these methods. Okay, sub answer back into one of the equations to get second answer. All right. Okay, let's go ahead and turn the page and finish our takeaways. Okay, on the second page, we've got a definition for a linear combination. So a linear combination is a sum of linear terms. Okay, and here's an example. We have, let's see, we have 2x plus 3y equals 6. Here's our sum of linear terms, right? Sum of linear terms. Here's our total that they sum to, and this whole thing is considered a linear combination. All right, I hope that this helps you with the second half of lesson 5.1, Business Sense. I wish you good luck on your practice.